About the on-site demo for the system, you can see this is the Flash 810 system. Okay. Now with the starting point, I would like to show you the complete flow of as to how the system works rather than switching it on. So we tend to do that in a later stage. So now on one side you see these are the 4 bottles. Okay. These would be your solvent system. This could be your mobile phase, and you see there are lines which are there inside. So now each line could go inside each individual bottle, and then it would act as a one single line. So from there, whatever mobile phase the system start point is, it gets sucked over here from this particular solvent, and then it goes in behind, and you see over here this is the pump, okay, for the system. In this pump, if you see, these are the 3, it's actually an inert pump. So, and basically if we talk about this, there are 3 pistons over here. 3 piston pump the solvent in a 120-degree way. So 120, when one piston sucks in, so the other one sucks out. So in this way, 120, 120, it makes a complete rotation and create a complete circumference for the circle. And then what happens is, in order to have a pulse-free flow, such inert pump or 3 piston has been used. And then from there you see the solvent getting sucked in over here, and this again you see this solvent going in towards your column or else towards your loader. So from here, the line you can see over here, where actually we keep our stationary phase, that would be our mobile phase going inside the stationary phase over, and we keep our loader on top. And then from here you see the outlet of the solid stationary phase, that would be your column, something like this, which will come over here. So the outlet goes inside the system towards the detector side. So whatever absorbance it comes in, it gets detected. So if there is a peak, it will get collected automatically over here. Whereas if there won't be any peak, by default there is a 3-phase valve. So one goes to waste, another one comes to the fraction collector. So in that particular way, it ends up towards the waste line. Okay. So this is the normal flow of the complete system. So I just switch the system on. The beauty of the instrument is purification as such can happen in a gravity way as well as in an anti-gravity way. Now if I want to do my separation in a gravity way, this is the way how actually we connect. And if I have to do an anti-gravity separation, I just have to take this out, plug out, just put it the other way around, and now in this way I have installed the system in an anti-gravity way. So now talking about the system once it's on, you can see this is this interface where actually the complete process of operation can be done with this one particular screen. You see there are different modules. Okay, we convert this complete module in 4 different parts. First is your column part, where actually the details of all the column, the flow rate, what would be the equilibration according to your column, what should be your approximate run length, everything can be put in from that particular. Here this detection module, that's the detection part. You see over here, that's the slope detection. Then there is a UV, the sensitivity option. The UV sensitivity, you know, it's indicating as high and low. This is another good feature where actually you can save quite a good amount of intensity for a particular UV. So if you are loading too much, if you are loading somewhere in grams, or a gram, 500 mg, you can keep your sensitivity to be at a low side. But when you're dealing in mg level, I mean to say 5 mg, 10 mg, at that time you want to have your sensitivity towards the higher side, right? So that's at that time we can select high. Over here, it's the threshold detection. Now everybody might be aware of what the threshold is, because as it is an automated system, we need to assign a particular value beyond which we would like to have a collection. And then over here, if we check, there are 4 wavelengths. So being a system having a PDA detector, so in this you can select any UV, that is 4 wavelength plus a scan function altogether, being a PDA detector. So automatically it will collect everything getting detected within 200 to 800 or any wavelength you have. The best part is that you can, if you see over here, there's 1 tick, right? So that means it will be collecting anything getting absorbed at 254. If I just click one time, the same thing, it says monitoring. So sometimes what happens is, if it is unknown, we don't want to collect it, we just want to monitor as to what would be the best, whether how the outcome would be like for the wavelength for that particular analyte on monitor. So So you will be able to see the peak difference, the peak height and everything based on particular monitor itself. And then again if you click it, then it is off. So in this way you have three options. One is off, one is collect, another one is monitor. And that's again last but not the least the best part, the UV scan function. In the UV scan function it clears a complete pattern of the complete range, that is from 200 to particular start point and the end point, whether you want to keep it from 200 to 400 or 200 to 800, 200 to 300, based on, we come down to the collection part. Now over here you can see this particular part over here, that's represent the collection part of your, you see the collect peak option, you have the collect all option and collect none. These terminology, it's a self-explanatory ones, like collect peaks, it will just collect the peak, collect all means it will collect everything, collect none means it won't collect anything, everything would go in the waste. Over here you see the two racks, alright. So based on the rack, what you see over here, that comes with the RFID. So if I take the rack out, see automatically it just diminishes. So if I just put it back again, you have both the racks coming in. So based on the RFID tag as well as it has detected the volume for this particular rack, it is 25 ml. So this is about the column, the detector sensitivity and the collection part. Now the most important part, that is the mobile phase as well as the gradient program part. So over here you see the solvent A, B, C, D. Alright. So in this A, B, C, D, either all the 4 lines which are there, whatever we do per prime with particular line with, so that it will be getting reflected over here. Over here you see that's your gradient, where actually on one axis you can see that's the second solvent percentage, that is 0, 20, 40, 60, 50 and 100 up till 100, and on the other axis what you see, x-axis, you see the time, that's your run length for your time. The best part is either you can play with regards to the plotting of points like this, because gradient can happen between any of the two. You can even plot a gradient table, or else you can even plot a graph. Create a gradient of all these combination what you see, that is with regards to AB, AC, AD, BC, BD and CD. So you do have an option. So now on one other benefit you can see, based on the run length and other parameters, automatically it hints based on the gradient what we have kept, it gives a complete idea as to how much your solvent consumption will be. Other than that, there are tools. If you see, this is, I think so, your natural product extract, right? So for that we developed a method in the hexane ethyl acetate, right? So now what we do is we prime the system with hexane and ethyl acetate. Go to solvent loading and this screen automatically pops up, different line 1, line 2, line 3. This is one way. Another way is you can directly click over here, and over here also you do have an option of load a solvent. So in this particular way, in line 1, if we select, rather than acetone, we just need to select, what we'll select? We'll select hexane, S1 and S2. So this column, so this comes along with the RFID. So the best part over here, on top of the instrument there is an RFID detector. So as soon as I place this column over here, it automatically detects which column is it. So you see now this one is the ID white pore 4 gram column. So automatically based on the RFID tag, it has detected this particular column. Now as you see, we don't have a bigger test tubes, right? So that means based on it won't collect 25 ml. So over here we need to be careful and we place it at 10 ml. I think so it's a 10 ml tube here. So we place it both non-peak and peak to be at 10 ml. Alright. And now the most important part is the gradient. Okay. Either I could make through the table, I could utilize this table, or else I could utilize directly from the graph plot. Now in this particular way, every time the equilibration will happen with the 100% non-polar compound, that would be our hexane, right? Line 1 will be utilized. So anyways, what I do initially for 3-4 minutes, I keep it hexane running in through my column, and then based on the TLC, so based on that I keep the run I don't go to 100%. So it's 20%. I keep maximum at 40 or 50. Let's keep it at 50. Now this is just a rough this thing. During the run, based on our need, we could even change it. Okay. So as a start, we just keep it at a rough based on the TLC data we have. So now after plotting the graph, we just need to click, you see, this play button. Okay. So once we click this particular play button, you need to just analyze whether everything is okay. So over here, by mistake, it got collected to collect all. So I have put it to collect peak only option. And now as soon as I press play button, okay. No, we have, I'll come to that. Don't worry. Okay. So we'll come to that as well. The system will tell you as to when you have to put your sample, load your sample. So now for an example, there will be set of scientists involved using the system, so they could create their individual folder in the name of, like, for an example, you can have your Dr. Sejal like one folder, your Dr. Sneha as another folder, and then inside your folder you can create your run. So everything later down the line, once you have done the run, you can even take your data out based on that. So now for this, we keep it, you see the date and the time comes in, and then you can just put your sample ID. You might be having some sample ID or PA. Okay, I just put it as PA test. All right, and then okay, I press OK. As soon as I press OK, the sample loading option come into picture. Now you see there are multiple options over here. The lower flow rate for specified time after injection. Now this is very much crucial and important when we are doing with the reverse phase. Okay, in the reverse phase, what happen is we generally do liquid injection. In solid, it's of not that use, but when you do it in liquid injection, in order the sample to saturate or in order the sample to be inside the column, we use this. So that is the reason when we do liquid injection, we tend to click this particular option and we give, like, for an example, now for another, if we have kept 40 ml, we could keep it somewhere around 20 ml or 50% of the flow rate what is defined within the system, and then for a particular time amount, so that it retains, it saturates well within the system or within the column. Okay, so this is option. This is only meant when we do reverse or else for liquid injection. Now flush second solvent at the end of the run. So during end of the run, like once the sample is everything out, what we could do is we could flush the second line. That would be our polar solvent. So even in order to clean, from clean point of view, we could click that. And then you see the left tray is available, the right tray is available. Now in this slide, so for us both the trays are available, so we click both the trays. Now then there is an another option which enlightens is the override start while. In override start while, what actually happened is, now for an example, now Dr. Sejal has run one application and she has just utilized a couple of rows of this particular, and then suddenly you want to use the system. So in that particular, if you are not aware as to what exactly are this, so rather than the first tube which you see black, this is every time the waste. The line which is there from the bypass till the fraction collector, that line also gets cleaned for every run. So that is why you see for every this thing we have this black color spot for the first. So now we could put, now for an example, your first application went till tube number 10. So what we could do is, behind this all the test tubes are empty, so we could give it as a starting point from 11. So in this way, rather than affecting your purification, we could start with that. Okay. Once the equilibration phase is over, the system will automatically pop a message of yes, insert your solid load. Over here you can easily see the equilibration column time, which is 0.2 minutes left. The second solvent percentage, which is 0, we are equilibrating it with the non-polar solvent, that's hexane. And then the solvent pressure, as to how much the pressure is within the system, it's even giving that particular. Now you see once it reaches, so as I mentioned, the first thing is every time dark, so it is cleaning my line from the fraction collector line. So you see it's getting, now it is moved to the next tube for the collection, and now our run. Install the solid loader and then press start, right? This is the lure. I take this lure out, and I then connect the lure over here. Alright, and then I'm not placing it on top over here, I just click start. Now I'll tell you the reason why I haven't placed my solid loader on top till now. Because you see, this is already wet, it's conditioned, and over here it's air, it's empty. So I'll just see as soon as the sample is ready. You see it's now getting wet, right? You see this is wet, and still nothing is coming out from here. If I would have placed it over here, all this air would have gone inside this column and it would have affected to some or the other way the separation part. So as soon as I see that it's reaching over here, minute air, it's okay. And as soon as I see that it's over here, what I do is I directly place it on top of and place it. So now in this way, my sample is now started for the purification. So as you can see, it's over here. There are other options which comes up while the run is on, that is the auto gradient hold and the gradient hold. So I'll just quickly tell you the difference between auto gradient hold and a gradient hold. Gradient hold is something like a manual thing which we click it. Now we have some peak coming in. So in that particular, if the peak coming in at what percent of the second solvent, if I put it to gradient hold, it will stick to that particular gradient. In auto gradient hold, what actually happen is, if I click it auto gradient hold, automatically the peak starts coming in, the system hold the gradient by himself. And once the peaks comes down and starts again, so the gradient automatically starts again. So this is one another good feature which you can have. So now there are in options, if you see, there are a couple of options of auto scale or manual. So in manual, if I want to zoom and check, so I put it the Y minimum to be 0 and maximum, so it will just give me a more clear picture as to if there is some impurities or minute things which are coming out or not. From here you see there is an edit option. If you scroll, it's a view option, and then this is a zoom option. So over here, if you see, there is a block which shows the test tube sign, right? So in between, if I want to manually change to another test tube, so I just need to click that particular. So now once the run is done, I've stopped the run. Okay, so this is the screen how the image gonna be. Now either you can see over here, as I mentioned, you can take your data out directly by connecting a USB. Whether the USB connection is just right beside my finger over here, and even there are 1 or 2 USB connections which you can even connect from behind. Okay, and then PDF to USB. So directly what happens is, if you have that the pen drive, the pen drive, you can easily connect pen drive, and directly if you put the option PDF to USB, so the rather than the data, it will give a PDF would be going into this thing, or else there is an option of close.
If I want to save it on the desktop.
Okay, so now for that, now if you talk about that particular part, so what I have to do is I go to file and I just do print run report. Okay, so in print run report, what happens is it automatically creates a PDF. Now try OK. So now this screen comes in as to, now this is your PA test, whatever name we have set, and then either you have to create it, you can put it in the desktop. Now if I just click save, so now it is the PDF as such is saved on the desktop. So in order to see that PDF, we go to file, we go to exit. Are you sure? Yes. And now this is my desktop, right? So in desktop, you see this is the PDF which I have saved. The run gets saved automatically. So the same thing, you can even give a command of PDF to USB. So automatically what happens is, so now you see this is my complete PDF file of your run about your collection. Now these are the 2 peaks. Now imagine, now these are so clean, right? Now if we check the UV scan detail of these 2 particular peaks, okay, you will see the difference. You see, You see? You see? It directly, if I see the lambda max, it's best at you. So, and it's one single spot. It's just for testing purpose, yes, before. So now you can easily figure out, right? Now this is so clean, one single spot. It's not a pattern which we have seen earlier, right? There were so many, this thing, multiple. And over here also if you see it's one single.